I'm just going to do a short video on the fundamental theorem of algebra. So this explains how to do the problems 6 through 8 in part 2 of the final review. I just think it's something you could get right on the final, so I'm just going to explain it pretty quickly in this 5-minute video. So basically what the fundamental theorem of algebra says is that for every degree in an equation there is a solution. So for a first degree equation here where it's y equals x to the first minus 1, there's going to be one solution. So that solution would be 1, 0, which would be x equals 1. Second degree equation like this one, y equals x squared minus 1, there'll be two solutions. So if you factor this one, you get x plus 1 and x minus 1. So those are the two zeros of that function. So those are the two solutions. For a third degree function, like this one, y equals x cubed plus 2x squared minus 2x minus 4, there will be three solutions. If you graph it, I've graphed it here, so here are the solutions. So you see the solutions here are negative 2, 0, negative 1.414, and 1.414. So I happen to know that 1.414 is the same thing as root 2. So if you factor this, it ends up, you get x plus 2 and x plus root 2. So the three solutions are x equals negative 2, x equals root 2, and x equals negative root 2. If there was a fourth degree function, there would be four solutions. Fifth degree function, if it was x to the fifth, y equals x to the fifth, there would be 5 solutions for x that would work. So there's always going to be, for the degree of the function. So if it's like a fifth degree function like this, there will be 5 solutions. So this is going to factor into, x plus something, x minus something else, x minus something else, x minus something else, x minus something else. But some of these may be irrational or complex numbers. So in part of the fundamental theorem of algebra says that if a root is an irrational number like root 2, or then the conjugate of this will also be a root. So the conjugate of root 2 is negative root 2. If the root is a complex number like 1 minus I, then the conjugate of this will also be a root. 1 plus root I. So I'll show you an example of this. Let's say you have a second degree function like y equals x squared minus 2. To get the zeros of this, we set y equal to 0, and then we factor this. So I guess one way we could factor it is just to solve by taking the square root. Let's see, so we get y equals x squared minus 2, and then add 2 to both sides, and then take the square root of both sides, and so the answer will be plus or minus root 2. The two solutions are x equals root 2 and the conjugate of that, which is negative root 2. So this happens also with complex numbers. So if you had more, this is a second degree function, y equals 2x squared plus 4x plus 6. So that's going to be second degree, so there'll be two solutions. Yeah, so we're going to solve this one by plugging everything into the quadratic formula. So here we go. So x equals negative b is negative 4 plus or minus b squared, so that's 4. So we're going to get a complex number because we got, negative 4. If we factor out 16, so square root of 16 is 4. And then we have I, and then root 2. Divide everything by 4. So the solutions are x equals negative 1 plus I root 2. And then the conjugate which is negative 1 minus I root 2. All right, so in number 6, you have a third degree polynomial. So that means it's going to have how many solutions? It's going to have 3 solutions since it's a third degree polynomial. So one of the solutions is 5. The other solution is 4 plus 3i. And then there's another solution. So the fundamental theorem of algebra tells us that anytime there's a irrational solution or a complex solution, the conjugate of that will be a solution. So we're not going to be looking for the conjugate of this integer since it's not irrational and it's not a complex. But this is a complex number, and the conjugate of this is 4 minus 3i. And that gives us all the solutions we need. So that's how you do that one.